So in order to have relative mins, you have to deal with continuous functions where the derivative of that function is changing from negative to positive, or you can look at a graph and talk about the outputs and compare outputs that are smaller than other outputs. So for part D, or part C, no, D, we want to look at our derivative. And because it's even, we're going to look at the derivative of just the right side. So I'm going to look just at the branch that is this piece. So this is my right branch. When I take the derivative of that, I'll have a low d high minus a high d low over a low squared. So that gives me a 3 ln of x minus a 3 over log natural of x quantity squared. We need to know when this is 0 and when this is undefined. So it will be 0 when the top is 0. So that's going to happen when 3 ln of x equals 3, or when ln of x equals 1, and that occurs when x is e. And then the undefined is when the bottom is 0, which occurs when x is 1, which we already knew because we threw that out with the domain way up at the beginning. So if we look now at the sign chart for f prime, we know at 0 that we have a discontinuity and we're undefined. We know that the limit as I'm approaching that 0 is going to be 0. But we've got a discontinuity there, so somewhere along the way we'll probably sketch a graph of f that helps us. We also know that at 1 we're going to have an undefined, and in this case, if we go all the way back up to the beginning, when I plug in a 1, I'm dividing by 0, and it's not a 0 on the top, so that means it will be manifested graphically as an asymptote. So I can put this asymptote here. Same thing on the other side. Because of the even nature of the function, I can put a negative 1 here with another asymptote. And then we have this x equals e. Because x equals e is a critical point as well, we need to put that on along with negative e. So now we're ready to test the signs. So again, since we're looking only at the right side right now, that means we're only going to be plugging in values on the right side, and then we'll sketch and do the mirror image on the other side. So looking here, we have something between 0 and 1 is a half. If I plug in a half here, this will be a negative number. So 3 times a negative minus another 3, that's going to end up being negative on top, and the bottom, since it's squared, will be positive. So in between here, I'm going to have a negative value. In between 1 and e, say at probably half of an e, I can plug in a half of an e. That would be, well, we actually get a calculator on this, so I'm going to let you just plug, I don't know, 2 in. Log natural of 2 times 3 minus 3. We're going to end up again with a negative number. And since you have a calculator, I'm going to trust that you could plug that into your y editor and just evaluate it at particular points. After e, say at e squared, this would be a 6 minus a 3. That's going to be a positive number on top and a positive number on the bottom. So that means my original function is going to fall toward this asymptote, and then it has a negative negative slope after that. So that means I'm going to fall again from that asymptote. I'm going to bottom out at e, and then I have to rise again. So because of the symmetry, we know the other side is going to do the same sort of behavior. And the only thing left is this weird discontinuity. So we know that the limit ended up at 0. So this is like our x-axis. And here's our y-axis. Doesn't really go with my number line, but you get the gist. And we know the point, when I plugged in 0, I got a 2 out. So if you sketch this on your by hand, or you put it on your calculator and plug it in, you're going to see this shape. You just won't see the hole unless you actually trace to it. So the whole goal of doing this analysis is we wanted to figure out what the minimums were. So we can see that we're bottoming out here and here. So I want the relative coordinates of the minimums. So that means I need to find the mins. So F is going to have mins at plus or minus E, comma, whatever, because if we look at those min values, we actually have continuity. So we write F is continuous at plus or minus E, and F prime, notice I'm naming the function. I'm not saying it, I'm not saying the slope, I'm not saying the derivative, I'm saying the function F, and the function F prime changes from negative to positive. Now we just need the y coordinate, so I'm going to take that E and plug it into the function. So this is the derivative. I got to go all the way back to the function branch. If I plug in an E, I get a 3e over a 1. So that's a 3e. That's my y coordinate. So the breakdown of points on this, we get 4 of them. We get 1 point for taking the derivative of the right branch. We get 1 point for identifying the critical values, which are E, and then 1 was an issue and 0 was an issue. And then we need to see the other ones on the other side. We get another point for the minimum y coordinates, and we get our final point for the justification. So 4 points here. Our final point is going to come from finding the coordinates of all the relative maximum points and then justifying. So if we look at our picture, we can see that we have a relative max here, but our normal conversation about slope and the change of sign in F prime is not going to be effective here because the function is not continuous. So in this case, we're going to have to make an argument based on the y coordinates. So in part D, we will say F of 0, which is 2, is a local max because F of 0, actually, we'll just say is greater. I was going to say 2 equals. I guess it wouldn't matter which one you use, because this value is greater than F of x for all x's in the interval from -1 to 1. We can't say for all x's because it's not a global extreme, it's only a local extreme. So we're going to just take this branch here. We're going to go from asymptote to asymptote, and we can see that every single y value that we generate in the function coming from -1 to 1 is going to be underneath that one. So this point, you get 1 point for finding the coordinates, which would be 0, 2, and the reasoning. And we're done.